So for the second type of this section, using the number line to uh, help solve a given ratio. So in this case, they give you this formula here. We didn't really use it on the last one, and it really just depends on what type of number line you have. Excuse me. So all these parts, right? So x1 is obviously the left point, x2 is obviously the right point. M and n are referring to the two pieces of the ratio that you have here and here. Notice how they flip-flop them when they're multiplying. So n is getting multiplied to the x1, m is getting multiplied to the x2, and then you add their total results for their ratio because it's referring to your entire piece going across. So that's what we're going to do first. So as you can see with example 3, they went ahead and they've already added up the total. In other words, this number line can be represented into 7 sections. And if you look at the sections, they are not like nice numbers. Typically, when you do these, you can kind of not use the formula if they give you like nice numbers. In this case, unfortunately, you can't break this number line into even parts. So we're going to go ahead and use the formula to help us figure that out because it's not going to be a nice number in the end. So add the two bottom numbers together. That's going to, or add the two ratios together, and that's going to give you 7. So m plus n is 7. That's the bottom of your new number that you're going to find. Now take your two endpoints and multiply them by the opposite version. So 4 is going to come over here. 3 is going to come over here. So 4 times the -5. Okay, 4 times -5. We're going to add it to the 7 times 3 and then see what we get. So we got 20, -20 plus 21, which is 1/7. So even though you could count technically 3 on one side, dot 4 on the other, that's 4, that's 3. If it was a nice number, you'd be like, oh yeah, it's 0. But they're not. They're not right on the line. Okay. If it was me, I would break this up into 7 parts. Hopefully they're all even. And then you could just arrive at your answer. But in this example, 1/7 is going to be your answer because it's a decimal or a fractional version of the number line that they have. So let's look at another one. It was located at 1/7. See how it's a little bit past 0? Yeah, it's not a great situation. So let's see if we can do the cheat on this one. So this one, I got a total of 4, and I'm adding 1 plus 3. 1 and 3 together. So let's see what our distance is. Our distance is 16. So I got -15 plus, minus 1, which is -16 or 16 altogether. Now this one we can go ahead and use cheat. So I'm going to go ahead and do that. So I'm going to break it up into 4 sections. And the reason why you can tell us this is because 16 is divisible by 4. The other one, our 12 distance, wasn't divisible by 7. So that's why you get ugly numbers at the end. So I'm going to break this up into 4 pieces. There's 1, 2, 3, and 4. Okay, so my goal here is to have 1 on the left and then a total of 3 on the right. So where that breaking point is right here. 1 here, 3 here. So my point is going to be at -13. That's P. Now this was a nice one where we could use the cheat. If that does not happen, like you can't break your total number line up into different parts, then you have to result back to the formula.